So, good morning guys. In the video lecture we had covered about the basics of the stress and the strains. Okay, let's cover that video in a very surprised way. And today we'll cover about the principal stress and principal strains. Okay, this is our concept today. So, first I wrap up what I have covered in the video section. Suppose if there is a body there and the forces are applied on the body and it is at 90 degrees, then it is becomes the normal stress. Okay, this is P, and the resistive forces that work by the body against that force is the normal stress. And the deformation due to the application of the load, it becomes the, after in the initial this was this one, and after loading it changes position, so it becomes the change in length by original length. This is the strain. Okay, now we have covered that. Here the body is when the forces are applied at 90 degrees, and the shear stresses are when the forces are applied on the edges of the body. But if when the forces are applied not at an angle but at a specified angle, not at 90 degree but at a specified angle, so at that point we take a new terminology which is called principal stress. And due to the application of force, there is a deformation in the body, and that deformation results to principal strain. Okay, this is our concept of the principal stress and principal strain, and this is a combined factor of normal stress and shear stress, and this is a combined factor of normal strain and shear strain. Okay, so principal stress is a combine of normal and shear. Principal strain is the combine of normal strain over shear strain. Okay, and what is the formulas of the normal stress is equal to force per unit area. Units are Newton per meter square or megapascal or pascals that are covered in the session. And this is a dimensionless unit because change in length would be in meters, original length meters, cancel out. So this is a dimensionless unit. Okay. Now we focus completely on the principal stress and the principal strain in this session. So the principal stress, it is consist of the stress in the x-axis, stress in y-axis, and the shear stress is a combination of the x-axis and the y-axis. Hello.
Hello.
Just recording the session.
Hello.
Recording the session. I'm recording the session. You please sit over.
Mr. Shah.
Just for this. Good morning.
We're recording the session.
Okay.
Where's the camera?
So it begins with
Wherever you want.
average normal stress, add and subtract the radial stress, and the final equation becomes the average plus minus the radial stress. Okay. And the formulations of the principal stress is the sigma x plus sigma y by 2 plus minus square root of sigma x minus sigma y by 2 whole square plus tau square x of y. This is the formulation we calculate with the principal stress and the principal strains. This is the normal stress. This is the normal stress. Here it comes with the average normal stress is here, and this is the radius of the this one, and this is addition. And if we need to calculate the maximum shear stress. It will be sigma x plus sigma y by 2 plus under root of sigma x minus sigma y by 2 whole square plus tau square xy. And for the principal stress minimum, it would be sigma x plus sigma y by 2 minus of sigma x minus sigma y by 2 whole square plus tau square x of y. This is the maximum principal stress and the minimum principal stress. Let's do an example. Suppose there is a body, a steel plate, having the stress components are 80 is the sigma x tensile stress, is the compressive stress, and the shear stress of the 30 megapascals. And we need to calculate the principal stress, maximum shear stress, and the orientations. Because orientations means when the forces are applied at a specified angle to that body, then what would be the angle, what would the theta, we will calculate through this orientation of the principal stresses. So, as discussed below, the formulations of the principal stress are sigma x plus sigma y by 2 plus minus under root of sigma x minus sigma y by 2 whole square plus tau square x of y. So, this x 80, this y 20, and this shear over here. We immediately put the values there. Here it is a compressive stress, so it will be the negative sign. So we put the negative sign over there, and the first we get the average of the normal stress, sigma x plus sigma y by 2. It is the 80 plus minus 20 by 2 is 30 megapascals. Now we calculate about the principal stress maximum minimum. 30 plus minus sigma x minus sigma y by 2 we calculate from here, and that is sigma x minus sigma y by 2 whole square plus tau square x of y. What was, we follow this one, sigma x minus sigma y by 2. So it was 80 minus 20 by 2, it will be the 100 by 2, 50. So we put the 50 over there. Third one, it is the shear stress. It is the 30 megapascal. We put the values over there, and here by solving this one, we get the shear principal stress of 58.31 megapascals. This is the, and maximum one is the 88, minimum one, because if we need to calculate, we'll put the plus over there. If it's the minimum, then we'll put the negative over there. So this is the principal stresses, max and minimum. Second step, we need to calculate about the maximum shear stress. So the formulations of the maximum shear stress is the square root of x minus sigma x minus sigma y whole square plus tau square x of y. Let's solve this one first. It was 80 minus 20 by 2 whole square plus 30 whole square. So it was 50, it was 30, it is the 58.31. This is the maximum value of the shear stress. Now the third point, we need to calculate about the what is the orientation of principal stress, at which angle the forces are applied, and it is making a specified angle with the x-axis or y-axis. So formulations are tan of 2 theta is equal to 2 tau xy divided by sigma x minus sigma y. So this is the shear stress we calculate from here. it is given in the formulation 30, here 80, and it is minus 20. We input the values there and we get the tan of 2 theta is equal to 0.6. 2 theta is equal to tan inverse, we put this value over there 0.6, and now with using the scientific calculator we can find our angle was the 15.48 degrees, means the forces that applied on that body, it has an angle of 15.48 degrees. Okay, this is the orientation of the principal stresses. So this is the entire concept of the calculating the principal stress and what would be the orientation of the principal stress, orientation of the principal planes on the body. In the similar manner, we calculate about the principal strain. Here, the two values are added up: maximum strain, minimum strain, Poisson ratio, and the Young modulus. And what are the strain, what is Poisson ratio, and what is Young modulus? Already covered in the online session. So,
This is for exam, yeah?
yes, this is for example. And here,
It's all for example. Which exam?
Exam, 8th of August.
so we calculate the principal strain components. The formulations are E of xy principal stresses is the Ex plus Ey by 2 plus minus Ex minus Ey by 2 whole square plus gamma square x of y. This is the shear strain and this is the our tensile strain, compressive strain. Here I have given the values, we have provided with the tensile strain, the compressive strain and the shear strain. We will use that formulas there. This is the formulations. Ex will be there, Ey we provided there, and we have to find, that is the shear strain is been provided by there. We put the values. So firstly we will find the normal strain. It is the sigma x plus sigma y by 2. It is minus 200. So we put the values and we get the values of the sigma x plus sigma y normal is 150 to 10 raised to power minus 6. Now we come with the second point is the sigma x minus sigma e by 2. It will be 500 minus 200 by 2. This is our value of the radius of strain, and this is the shear strain. We put all the values in this formulations and solving this one, we get the values equal to the maximum principal stress and principal strain. Okay. So this is the way we find the values of the principal stress and principal strain. Another thing, final, what would be the orientation of principal strain? The same formulations. Tan of 2 theta is equal to shear strain divided by tensile strain over the compressive strain. We'll put the values there and we get the final answer of the tan of 2 theta is equal to 0.571. 2 theta is equal to tan of inverse 0.571, and the theta would be is the 29.7. Theta p is equal to by 2, it will be 14.85. Okay, this is we calculate the orientation of principal strain. So prepare for these lectures. Half of the lecture is provided online where you get get the knowledge about the stress and strain, and this is the principal stress and principal strain, which is surely will come in the examination, a very important point of view. Okay. So thank you so much.
Thank you.
You're welcome.